We're going to be doing a complete course review covering systems of linear relations, centers of triangles, quadratic, and trig. Let's start off with systems of linear relations. So for the first question here, they want you to solve this system of linear relations using the graphing method. There's two main types for graphing. You can either solve using x and y intercepts, or you can also solve using the point-slope method. So for the first equation here, let's go ahead and do this using x-y intercepts. So if I want to find my x-intercept, we're going to set y equal to 0. And setting y equal to 0 here, we get x equals 4. Next, to find my y-intercept, I'm going to go ahead and set x equal to 0, in which case we get 0 minus y is 4, negative y is 4, so y equals negative 4. So this equation 1, this linear equation, has x-intercept at 4. Let's go ahead and plot that. 1, 2, 3, 4, and a y-intercept at negative 4. 1, 2, 3, 4. Connecting these up, we have our linear relation. And this will be our, let's label this L1 for our first line. The second method to solve for is to put your equation in y equals mx plus b form. So in this case here, this would be y equals negative 2x minus 4. The slope of this line is negative 2, or negative 2 over 1. So how it works here is typically the numerator is your rise and the bottom is your run. So in this case here, we start at our y-intercept. Notice my y-intercept is negative 4. I've already found my intersection point. It's right here. But to continue the graph so you can see the method, you start your y-intercept, in this case negative 4. Because of the negative 2 in the rise, we're going to go down 2 units and then positive 1 to the right, down 2, positive 1 to the right. As you can see, I'm completely off the graph, and I don't want to go this way. So equivalently, I can write this as 2 over negative 1. Now what I'm going to be doing is from my y-intercept, I'm going to be going up 2 units to the left 1, 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 and then you can plot your graphs. Let's go ahead and do that. So up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. You can continue on up 2 to the left 1. So connecting these all up together, we have our second linear equation. I'll label that L2. As we already observed here, we have our point of intersection, and the point of intersection of this line is going to be 0, negative 4. All right, let's take a look at solving using substitution. To solve using the substitution method, you pick a variable to isolate for. What I'm going to do, I'm going to isolate for y in equation 2, in which case I get y equals negative 5x minus 2. I'm going to then sub y equals negative 5x minus 2. I'm going to sub that into equation 1. So you end up getting 3x minus 4. Get rid of the y and put negative 5x minus 2. And then I can go ahead and distribute that negative 4, in which case I get 20x plus 8 is negative 15. 23x plus 8 is negative 15. 23x equals negative 23. X equals minus 1. So I get my x value is minus 1. I can go ahead, I can sub that into either equation. I'm going to sub negative 1 into, the easiest equation to use, to be honest, would be this one right here. Y equals negative 5x minus 2. You've already isolated for it. I might as well go ahead and sub that in which case I get y equals negative 5, negative 1 minus 2, y equals 5 minus 2, y equals 3. So now the point of intersection is negative 1 and 3. Now let's take a look at solving using elimination. To solve using elimination here, what you need to do is you need to pick a variable that you want to eliminate, either the x or the y. So what I'm going to do here is in equation 1, I'm going to multiply across by 4, in which case I get 20x plus 32y equals negative 8. In equation 2, I'm going to multiply across by 5, 20x plus 30y equals negative 10. In this situation here, you'll notice the x's are the same coefficient now. Therefore, the operation that's going to cancel off those x's is subtraction. 20x minus 20x is 0. Here I have 32y minus 30 is 2y, in which case I get y is 1. Now that we have our y value, I can sub it into either equation. I'm going to sub it into equation 1. So I have 5x, which is what I want to solve for, plus 8 times 1 is negative 2. 5x plus 8 is negative 2. 5x equals negative 10, and x equals negative 2. And I've got an x value here of negative 2. So the point of intersection here, and again, when you list your point of intersection, you go by alphabetical order. So in this case, negative 2 and 1. Notice if I wanted to do a quick check just to make sure I got that question right, what we're going to do here is I'm going to take this point here, negative 2 and 1. I'm going to sub it in to both equations. So I've got 5 times negative 2 plus 8 times 1. That's got to come out to be negative 2. Well, if I do the calculation on this, I get negative 10 plus 8, and that is in fact negative 2. Sub in this point into my second equation. You have to sub it into both, just to remind you. So x is negative 2, and y is going to be 1 here. We get negative 8 plus 6 is again negative 2. So satisfies both equations, and this is the point of intersection. So now in these questions here, we're given the option of solving using any method. So we can choose to solve it however we like here. So let's look at the first question here. So for this equation here, you'll take a look here. We've got fractions involved. Right away, before I tackle this here, clean everything up. So I'm going to take equation 1. I'm going to multiply across by 6, in which case I get 3x minus 2y is 6. Equation 2, I'm going to go ahead and multiply. So I multiply this by 6. I'm going to multiply this across by 4. I get 4x plus y is 8. And I'm going to go ahead and I'm going to solve this using substitution. So using substitution, I'm going to isolate for y, and then I'm going to sub that into equation 1. So I get 3x minus 2 plus 8 is 6. So I end up getting here 3x plus 8x minus 16 is 6. 11x minus 16 is 6. And I get my x value of 2 here. So now they got the x value of 2. I'm going to go ahead, I'm going to sub that into either equation. I'm going to sub that into equation, and again, you can use your simplified equations. I'm actually going to sub it into this equation right here, in which case we get y is negative 4 times 2 plus 8. End up getting here that y is 0. Okay, let's suppose you got this answer, you want to make sure that it is in fact correct here. I'm going to go sub it into both equations. So I'm getting my answer here is the point of intersection is 2, 0. Let's actually check this one. So I'm going to sub this into my first equation. And if I do that here, you'll notice that the left-hand side equals the right-hand side. I'm going to do this with the second one as well. So in place of the x, I'm going to put a 2. And in place of the y, I'm going to put a 0. And you'll see it satisfies the second equation as well. So taking a look here, I subbed this point into both equation 1 and equation 2, and it lined up. It was okay, so we're good. Okay, let's take a look at the next question. So for the next question here, I want to solve for a or b here. I'm going to go ahead. First thing I'm going to do with equation 1 is I'm going to multiply across by 3 and get rid of that fraction. So this becomes 18a minus 15b is 4. Equation 2, I'm just going to write that back down and see what we have here. Now I'm going to solve this using elimination. The easiest one to eliminate is going to be the b. So I'm going to take equation 2 and I'm going to multiply across by 5. So if I take equation 2, this is equation 2, and I multiply across by 5, I'm going to end up getting 50a plus 15b equals 30. Now I'm going to be comparing, let me just highlight these so we can see. I'm going to be comparing equation 1 and this sort of adjusted equation. Notice here that the coefficients are almost the same for the b's. If I use the operation of addition here, that's going to cancel those b's off. And in which case here, I'm left with 68a, right? Adding up my 18a plus 50a is 68a equals 34. Dividing that out, I end up getting here a equals a half. So my a value is a half. I can sub that into either to find my b value. I'm going to go ahead and sub it into equation 2, in which case we get 10 times a is a half plus 3b is 6. 5 plus 3b is 6. 3b is 1, and I get b as a third. So the answer to this question here, my point of intersection, again, just to remind you guys, when you're labeling your points, it goes up by alphabet, so alphabetical. So a comes first. So it's going to be a half, and then followed by b, which is a third. So point of intersection for this one is 1/2 and 1/3. All right, let's try another. Now these questions here are a little bit different. It says for each of the following system, so for each system here, describe the type of solution. And remember, there's no solution, infinite solution, or unique solution. Okay, so if I look at my first equation here, you'll notice equation 1, I can rewrite this. If I put this in lowest terms, we actually end up discovering that both our equations have the same slope. But these equations have the same slope, but they have different y-intercepts. If I were to do a quick little sketch of this here, same slopes, different y-intercepts, might look something like this, right? This would be, let's say this is line 1, this is line 2, here's line 1, here's line 2. So you can see here in this situation here, we have no solution, right? Same slopes, different y-intercepts will yield no solution. For our next equation here, you'll notice that right away we have different slopes. As soon as you have different slopes, right away you have unique solution. Of the three possibilities, right, you have no solution, infinite solution, or unique solution. No solution happens when you have same slopes, different y-intercepts. Infinite solution, you have to have the exact same equation. So the only alternative, the only option left is unique solution. So these two systems of equations cross exactly once. Slopes are different, crosses once. So this is because the slopes are different. All right, let's try the next one here. For a question like this, you'll see like, I don't really want to have to, I want to take a look at what the slopes are, but I don't want to have to isolate for y directly. This might help you out. If you have an equation in standard form, if I did go to solve for the slope here in general, what you end up getting here when you divide across by b, you end up getting, if you have an equation, and you probably remember this, if you have an equation in standard form, its slope is always negative a over b. So I have here line 1 and line 2. So if I look at line 1 is going to be negative a over b, so it's going to be negative 1 over root 2. And line 2, the slope of line 2 is going to be negative a, so negative 1 over b, which is minus a 3, so it's a third. So a quick check here, I can see that my slopes are different. Different slopes means we have a unique solution. All right, let's take a look at another. So now we get into word problems here. So if you're taking a look at these word problems here, we have a 60% sulfuric acid solution is mixed with a 95% solution and produces 2,700 milliliters at 70% concentration. How much of each is required? So this is a mixture question. You've got sort of like a mixture set here. The concentration is maybe 60%, and then you have another mixture here, a higher concentration of 95%. These are being put together, and you're going to create a new barrel, and that concentration level is 70%, and you're actually getting 2,700 milliliters of that particular liquid that they're creating. So with this problem here, what you're going to do is what they ask you to solve for, we're going to introduce the variables. So in this case here, I'm going to let, let's let x be the amount of milliliters at 60%, and I'm going to let y equal the amount of milliliters at 95%. I want to know how I can mix these together to get this 70% concentration. Well, right away, my first equation is going to be x plus y equals 2,700, right? Because I know that if I take the amount of milliliters at 60% plus 95%, has to come up to 2,700. My second equation here is going to be, I'm going to take 60% of my concentration from here. So for my 60% concentration, I'm going to multiply that by just the pure, in this case here, sulfuric acid, plus I'm going to grab 95% of however many milliliters I'm taking out of the y variable, and I know that that concentration level has to equal 2,700 times 0.70. So let's clean up these equations and see what we have. I have x plus y is 2,700, and my second equation is going to be 0.6 x plus 0.95y equals 2,700 times 0.7 is 1,890. So now I can solve this using substitution or elimination. I'm going to go ahead and do substitution on this. So if I do substitution, I get y equals 2,700 minus x. Therefore, I'm going to go here. I get 0.60x plus 0.95. Get rid of that y. It put 2,700 minus x is 1,890. And distribute that. This is negative 0.35x plus 2565 is 1,890. Get 1,928.57. Now I'm going to sub that in. I want to solve for y here. So I'm going to go to equation 1 here, and I'm going to substitute in our x value and solve for y here. So in this case here, you end up getting y equals the 2,700 minus 1928.57. So my y value comes out to be 771.14 milliliters. So putting this together here, just to kind of summarize, we're going to take, to create this mixture, take 1,928.57 milliliters at 60% and 771.14 milliliters at 95%. All right, let's take a look at another problem. So this question here, we have a box, has twice as many dimes as quarters, totaling 540. How many of each type of coin are there? Let D equal number of dimes, and I'm going to let Q equal number of quarters. So what I know here, I know that the box has twice as many dimes as quarters. So there's a lot more dimes than quarters. So if you look at the expression here, what I have here is the number of dimes is twice as many as the number of quarters. For these to equate, I have to take the number of quarters and double it. So there's my one equation. And let's go ahead and set up our second equation here. So my second equation here, I know the total comes out to 540. Well, if I take 10 cents times the number of dimes, plus take 0.25 times the number of quarters, that has to equal $5.40. In this case here, you're set up perfect for substitution. I'm going to go ahead and sub D into equation 2. So we get 0.10 times 2Q plus 0.25Q is 540. 0.20Q plus 0.25Q is 540. 0.45Q is 540, and I can divide out that Q and I get 12. So I end up getting here 12 quarters, and if there's 12 quarters, that must mean there's twice as many dimes, so there's 24 dimes. All right, let's look at the next problem. So for this question here, we have Andy travels 315 kilometers. They say in the question it is half as much by car at 60 kilometers an hour as by train at 75. How long did he travel by train and car? So right away, I'm going to let C equal time that you travel by car and T equal time that you travel by train. So I know, what do I know here? Well, I know half as much time by car as by train. So half as much time by car as by train. So if I take the time I traveled by car, I would have to take my time I traveled by train and multiply by 0.5. If you take a look here, the time traveled by car is half the time traveled by train. Half as much time by car as by train. Now, how do I relate this to a second equation? So I know if I take 60C, that's going to represent the distance I've traveled by car. And if I add that to 75T, that's going to represent the distance I've traveled by train. In total, that has to come up to 315 kilometers. So now that we have our two equations, once again, I'm set up kind of nicely for substitution here. I have C equals 1/2 T. So I'm going to sub that into equation 2 here. So I get 60 times 1/2 T plus 75T is 315, which is 30T plus 75T is 315. 105T is 315. Dividing that out, we get T equals 3 hours. And if T equals 3 hours by train, that means the car was half as much, so it's an hour and a half by car. So Andy here traveled 3 hours by train, going 75 kilometers an hour, and then an hour and a half by car, going 60 kilometers an hour. Okay, we want to take a look at the quadratics unit here. Quadratic's a pretty big unit here, so we're just going to follow along here. We're going to first start off with the idea of expanding and simplifying quadratics. Let's go ahead and do that with this first one here. So if I want to expand and simplify a quadratic here, if you remember, take care of what's in the brackets first. So if you remember here, I'm going to keep that 2 along for the ride. I'm going to go ahead and do FOIL on this here, in which case I get x squared minus 4x plus 3x minus 12. Before you go ahead and distribute that 2, you should always simplify first. Reduces your work. So in this case here, I'm going to take care of what's in the brackets first. I'm going to simplify this. Now I'm going to go ahead and distribute that 2. And we end up getting 2x squared minus 2x minus 24. That's expanded and simplified. Let's do the same with this one here. So same idea, expand this out. and we end up getting 6x squared plus 10x minus 3x minus 5. Collecting like terms here, I get 6x squared plus 7x minus 5. Okay, let's try some more. So this one here, again, same idea. Keep that minus 2, write it down, and we're going to do FOIL on the product of these two binomials here. So in this case here, you're going to get 5x plus 1 minus 15x squared minus 3x. Collect like terms. So in this case here, we've got the 5x and the minus 3x. So you end up getting negative 2 becomes 2x plus 1 minus 15x squared. Distribute that negative 2 into the trinomial, and we get negative 4x minus 2 plus 30x squared. We should rewrite this in descending order by degree. So in this case here, we get 30x squared minus 4x minus 2. And that becomes our quadratic, expanded and simplified. Okay, let's try another one here. So for this next one here, we're going to go ahead and, again, with the power of 2 here, you square the first. So let me write down the steps in between. We square the first, then we've got, you add that to the first, times the second, times 2, and then you square the last. So in this case here, you get 9x squared plus 12x plus 4. And now we're expanded and simplified. Let's continue. So with this one here, we want to almost take this as two separate questions. I'm going to first expand out this one here. So we get x squared plus 4x plus 4. And then with this one here, we're going to have expand this out, these values out here. Now don't forget that minus sign in front. So if I'm not going to forget that minus sign in front here, we're going to end up getting here x times x is x squared plus 2x plus 3x plus 6. Again, we end up getting x squared plus 4x plus 4 minus, simplify what's in the brackets here, you end up getting 5x plus 6. Now again, you got to distribute that minus sign into the brackets, in which case we get minus x squared minus 5x minus 6. And collecting like terms here, what happens? The x squareds cancel, and we end up getting 4x minus 5x is negative x, and positive 4 minus 6 is negative 2. You get negative x minus 2. Let's go ahead and take care of the next question here. So for the next question here, we've got here, we square the first. Again, the 3 is along for the ride, so we're going to write that back down. And we've got you square the first. First times second times 2 gives us negative 4x. And square the last, we get positive 4x squared. Plus, here I'm just going to distribute that x into the binomial, in which case we get 2x squared minus x. Now I can go ahead and distribute the 3 minus 12x plus 12x squared plus 2x squared minus x. Now we want to go ahead and collect some like terms here. I've got a minus 12x and a minus x here, and then likewise I've got a positive 12x squared and a positive 2x squared, in which case here we get 3 minus 13x plus 14x squared. And again, we should rewrite this in descending order by degree, so we put the 14x squared here, 13x plus 3. So now we're moving on to finding roots of quadratics. So to find roots of quadratics here, again, to find the roots, you set your y value equal to 0. They've actually already done that in these ones here. So if I want to find the roots for this, again, I have the product of two expressions is 0. My first expression is minus 1/2 x, and the next one is negative 2x minus 3. Well, the only way this can be 0 is either minus 1/2 x is 0 or 2x minus 3 is 0. Solving for x here, we multiply across by negative 2, let's say, and you end up getting x is 0. Alternatively, you could multiply across by 2 and then divide by negative 1. But anyways, when you go to solve this, you're going to get x is 0. For this one here, we're going to add 3 to both sides and divide by 2, and you get 3/2. So the roots of this equation are 0 and 3/2. Continuing on here, I have the product of two expressions is 0. There's only two options. Either 2x minus 5 is 0, or 1 minus 2x is 0. So either 2x is 5, in which case x is 5 over 2, or negative 2x equals negative 1, in which case x is 1/2. Two values here are x is 5 over 2 and x is 1/2. Moving on here. Now they want us to find the roots, but the quadratic isn't factored. So we have to go through our factoring techniques here. First thing you look for whenever you're factoring is a GCF. This first quadratic has a GCF of x. So I end up with an 2x plus 1 inside. Now I have the product of two expressions is 0. Either x is 0 or 2x plus 1 is 0. Solving for x, I get x is minus 1/2 here. Okay, let's continue on. So again, I have a quadratic. It's not factored. Again, you always want to look for GCF. So I see a GCF here of 7, so I'm going to factor that out first. 28 divided by 7 is 4, so I get 4x squared minus 1 is 0. Inside the brackets here, we can continue to factor this using difference of squares. I can rewrite this as 2x squared minus 1 squared. And now my difference of squares formula is going to be 2x minus 1, 2x plus 1. So now I have the product of two expressions is 0. Either 2x minus 1 is 0 or 2x plus 1 is 0, in which case x is equal to 1/2 or x equals minus 1/2. All right, so now I've got a quadratic here. I don't see a GCF on this one here. It looks like a complex trinomial. I don't have a leading coefficient of 1. So in this case here, you can factor this using charting or decomposition. I'm going to go ahead and do this using decomposition. So the product of this expression is going to be 10 times negative 3, which is negative 30. And the sum of this expression is going to be 1. I need to think of two numbers that multiply to be negative 30 and add to be 1. That's going to be 6 and negative 5. So I'm going to go ahead and I'm going to replace that x with a 6x minus 5x minus 3 is 0. GCF these here. I'm going to GCF a 2x out, in which case I'm left with 5x plus 3. GCF a minus sign out, in which case I'm also left with a 5x plus 3. And we're ended up with a 5x plus 3 on both. Factor that out, and you're left with a 2x minus 1 is 0. And we have the product of two expressions is 0. Either 5x plus 3 is 0 or 2x minus 1 is 0, in which case x is equal to minus 3/2 or x is equal to 1/2. Okay, continuing on here. So I've got a quadratic here. Again, you always want to look for a GCF. I see a GCF of negative 2 here. So factor in a negative 2, I get x squared plus 10x plus 24 is 0. I have a simple trinomial inside. Notice the leading coefficient is 1. So I need to think of two numbers that multiply to be 24 and add to be 10. Well, those two numbers are 6 and 4. So I can go ahead and rewrite this as x plus 6 times x plus 4 is 0. And again, I have the product of two expressions is 0. This minus 2 is not contributing to the product being 0, so I tend to ignore that one. It's not going to, there's no variable of x incorporated there, so it's not going to, there's nothing that I can do to make that go to 0. But I have choices for x plus 6, and I have choices for x plus 4 to make that go to 0. Namely, I can let x be negative 6, or I can let x be negative 4. Both of those will yield a product of 0, so those are of interest to us, and those are our roots. So this quadratic here crosses the x-axis at negative 6 and negative 4. Let's continue. So this quadratic here, same idea. I don't have a GCF. I'm going to have to factor this using charting or decomposition. I'm going to go ahead and do charting this time. So for charting, I write down all the factors of 5 and their flips. And then for the minus 27, all the combinations that come out to be a 27 here. And I'm looking for products such that if I take the product of diagonal terms and add them up, I get negative 42. And that combination becomes this column here and this column here. Notice here, if I take 1 times 3, you get 3, and 5 times negative 9, you get negative 45. So because of that, this quadratic will factor into x minus 9 and 5x plus 3 equals 0. So now I have the product of two expressions is 0. Either x minus 9 is 0 or 5x plus 3 is 0, in which case x is 9 or x is negative 3 over 5. So now in the next example here, I want to find the roots of the quadratic using the quadratic equation. So again, I have this quadratic, so I'm going to find my a value. A value is 1, b value is also 1, and c value is negative 5. Using our quadratic equation, we're going to get x equals negative b plus or minus the square root of b squared minus 4, my a value, c value, over 2 times a, in which case we get x equals negative 1 plus or minus the square root of 1 plus 20 over 2, which is negative 1 plus or minus the square root of 21 over 2. And this is our simplified form here. Notice here the root 21, I can't break that down anymore. So the answer here is negative 1 plus or minus the square root of 21 over 2. Okay, for this next question here, they want us to find the value of k such that this quadratic has exactly one root. Well, I know that if my discriminant of my quadratic is 0, then my quadratic has exactly one root. So therefore, what's the discriminant of this? Well, the discriminant in general is b squared minus 4ac. So my b value here is going to be negative 8. So negative 8 squared minus 4. My a value is 2k plus 1. And then the c value is 6. So I want to set that equal to 0. So this becomes 0 equals 64 minus 24, 2k plus 1. 0 equals 64 minus 48k minus 24. We get 0 equals 40 minus 48k. And solving for k here, I get k equals 40 over 48, which reduces to become 5 over 6. Moving on to the next question here, we want to express the following quadratic in vertex form by completing the square and using another method. So let's talk about that. I've got the quadratic here. I'm going to first do it using completing the square. So to complete the square in this, you factor the leading coefficient out of the first two terms. In this case, this becomes x squared plus 3x, and then minus 1. Identify your b value. My b value here is 3. I divide it by 2 and square it, which gives me 9 over 4. So that's the number I'm going to add and subtract. X squared plus 3x plus 9 over 4 minus 9 over 4 minus 1. The first three terms will factor. So this becomes y equals 4. Again, that becomes squared. Put our minus 9 over 4 down. And the square root of x squared is x. The square root of 9 over 4 is just going to be the 3 over 2. And you copy that sign down, in this case a positive. Now I can go ahead and distribute the 4. We get x plus 3 over 2 squared. And that 4 is also distributed to the negative 9 over 4, in which case we get negative 4 times 9 over 4 minus 1. And y is 4, x plus 3 half squared minus 9 minus 1. So now we have the following quadratic in vertex form, and we did this by completing the square. Another option to completing the square is when I have a quadratic here in standard form, and we know that the x-coordinate of the vertex occurs at negative b over 2a, which means in this case it'd be negative 12 over 2 times 4, and that's going to be negative 12 over 8, which is going to be negative 3 over 2. So now that I have the x-coordinate of my vertex, I can sub it back into my equation here. So everywhere I see an x, I'm going to change that to a negative 3 over 2. And this becomes 4, squaring the top and the bottom. Here, this will reduce to become a 6, so we get negative 18 out of this, minus 1. 4's will cancel. I get y is 9 minus 18 minus 1. And that's going to be negative 10. So therefore, the vertex is negative 3 halves and negative 10. From here, I know my vertex, as we just discussed. And I know that it's the same a value. So my a value here is if you take a look here, your a value here is a 4. So my quadratic in vertex form is going to have the same a value, and I just need to create a quadratic that has a vertex at negative 3 halves and minus 10, which would be this one here. So this is an alternative method to completing the square, where you use your negative b over 2a fact to go ahead and find your vertex, and then you just copy the same a value down. All right, let's take a look at the next question. Now for this question here, they're asking to find the vertex of the following quadratics. This quadratic is in vertex form. It's not written explicitly, but if I write this in explicit vertex form, the vertex of this quadratic is going to be 0, negative 1. This quadratic here, I can put a plus 0 at the end, in which case the vertex here will be negative 2 and 0. And this quadratic is in vertex form. It'll be negative 7 and 4. All right, let's take a look at the next ones here. Now for this question here, they want you to find the equation of the quadratic that passes through the point 9, 7 and has roots at 5 and 10. So if I have a quadratic that has roots at 5 and 10, I'm going to go right to factored form, and I'm going to create a quadratic that has roots at 5 and 10. So by inserting the x minus 5 and x minus 10, I now have roots at 5 and 10. I know it passes through this point here, so I'm going to sub this point into my quadratic, and that'll allow me to solve for a. So therefore y is going to be 7, and my x is going to be 9 here. And when I do my math on this, we get 4, negative 1. So I get a is negative 7 over 4. So putting this all together, we get y is negative 7 over 4, x minus 5, x minus 10. So the quadratic that passes through point 9, 7 and has roots at 5 and 10 is this one here. All right, let's try another. So for this question here, they want us to find the equation of a quadratic that passes through the point 1, negative 5 again, but now it has a vertex at 2 and 3. So because they're giving us the vertex here, I'm going to go to vertex form. So I need to put a quadratic in that has a vertex at 2 and 3. That would be this quadratic here. Once again, I need to find that a value, so I'm going to sub the point in. So my point here is negative 5 for my y value, and my x value is going to be a 1 here. And in which case here, we get negative 1 quantity squared plus 3. Subtracting, you get negative 8 is a times 1, so I get a is negative 8. So putting this all together, the quadratic that they're looking for is going to be y equals negative 8, x minus 2 squared plus 3. And now we have a quadratic in vertex form, and that's passed through point 1, negative 5, and has the vertex of 2 and 3. All right, let's try another. So for this question here, another find the equation of the quadratic. This time they tell us that we have an axis of symmetry of negative 3, a root at 4, and a y-intercept of 5. Now I don't know the direction of opening this quadratic. Let's assume it opens downwards, for instance. I know I have an axis of symmetry here of x equals negative 3, and I know it has at least one root. But because the root here is at a 4, and the axis of symmetry is at negative 3, I know the distance from the root to the axis of symmetry takes a distance of 7, which means that going on the left side of the graph, I must also have a distance of 7 and have my second root. So this quadratic has two different roots. One root is at 4, and the other root is 7 steps to the left of negative 3 because of the symmetry, which means that the other root is at negative 10. So now I have a quadratic with roots. Summarize this here, I have a quadratic with roots at 4 and negative 10. But on top of it, they tell us in the question that we have a y-intercept of 5. But a y-intercept of 5 is the same thing as saying that the quadratic passes through the point. You just have to express the y-intercept as a point, in which case that'd be 0, 5. So now this is back to an old question. I have two roots and I have a point, and I can find the equation of the quadratic. In this case here, we go to factored form. So now I got this will create a root at 4, and this will create a root at 10. I can now sub the point into here, so my y value is 5, and my x value is 0, and I'm getting 5 equals a negative 5 times 10, and these will cancel here. I get 1 equals negative 10a, so my a value here is negative 1 over 10. Putting this all together, my quadratic is y equals negative 1 over 10, x minus 4, x plus 10. And now we have a unique quadratic that satisfies these conditions.